Welcome back to my channel. If you are new to the channel, please subscribe to my channel. In my previous video, I've talked about method overloading. Now I'm going to talk one of the important concepts, that is inheritance. If you are new to the channel, please subscribe to the channel. If you have any doubt, please comment in my previous videos if you have any doubt. Right now I'm going to discuss inheritance. What is inheritance? It's a process of acquiring properties of one class even to other class, like acquiring properties from one class, that is superclass, to subclass. This process is known as inheritance. So this is inheritance, process of acquiring properties from one superclass to subclass is known as inheritance. Inheritance is achieved by using keyword called extends. So using this extends keyword, we can create inheritance. And one more thing is, like, superclass is also known as parent class. It's also known as a parent class, and the subclass is also called as child class. It's just like acquiring the properties of parent to the child. This is known as inheritance in simple terms. And there are 4 types of inheritance. One is, and actually there are more, but mainly generally used in everywhere, as single level inheritance, so multi-level inheritance. 3, hierarchical inheritance. 4, multiple inheritance. Mainly these are, still we have something like hybrid, and there's something like that. Mainly we use these things. So what is let's go on with the single level inheritance. A single child, a parent class going to have a single child for a single level inheritance. It's like, let me open Paint. So this is a class. This class is known as A. Increase the font. This class is A. Okay, this class A has a property of, let's say, int. This has a property, let's say, is going to be like, it has a value like I, which is an integer variable, I, which is equal to, it is going to be an integer variable. This is a superclass. This is a superclass which is going to have an integer variable, and we are going to have a subclass which is going to be a B. Let's say it's going to be a B. Which is B. This is class A and this is class B. So A is the superclass, B is the subclass. So how we are going to write is, in Java, class A, let's say I take an int that is I equal to 5, let's say. I'll take class B extends. See, this is the keyword which is used to in inheritance, extends A. I'll take an integer and again as, let's say, j equal to 6. And I'll say print ln, I'll print I value plus I. Print ln j value plus j. Okay, so let me do one more thing. I'll create a method that, let we say that method is like display method. I'll call this method. In this method I'm passing these variables. Now I'll call a class that is main class, and in that I'll call main method. You type main, you're going to get it. Just type main, you can get it. Now if you can print, now you can just call that B method. B, let's say I'll take P equal to new B method. Now I'll just want to display that, so I'm going to call the display method which we have created. And now if I run the code, return type is something missing. Display method. Class A, B. Okay, I'll call it as void public. Okay, I need to mention here return type, only then it's going to work. Now if I call it, see, in class B we only declared j value. If I going to remove this extends keyword, and if I run this code, it's going to throw an error because I cannot find I value. So what is happening here is when we write this extends A, this A class is called, so this class B going to extend the properties of A. So this B going to have the properties of A here. So when we write here extends, the A extends A, this A class is called in here. So when we call that value, then it's going to print. Let's say if I'm not going to print this value, we are not going to get I value here. But we not got an error. So here when we extend a class, we are going to call all the properties of that class to this, all the properties of this child class, parent class to this child class. So the parent class is going to call the properties of the child class. This is how the inheritance for a singular inheritance works. Hope you got how the singular inheritance is going to work. Now let me go for another inheritance. What is the second one which we are about to discuss? That's multi-level inheritance. So let me tell what is multi-level inheritance. Second one. Now if you see here, class A is extending class B. Now this is only a single class which is being extended, so that's the reason it's not a single level inheritance. Multi-level inheritance is nothing but having another class class that is, let's say, C, take it 18, call here C, so class C. So if you see here, class B properties is called in A and class C properties are called in B. Nothing but different extra classes added. That's the reason it's called multi-level inheritance. So just like this, I'll create another class here, class, I call it C. It's going to extend A. I'll call here int k equal to 25. Now here I'll create one more method like public void. Instead of display, I'll tell view. Or else let me do one thing. I don't take here that k value. Instead of that, in this k equal to, I'll tell I plus J semicolon. Now if I print a k value, oh sorry, here I need to call this view method as well. What is the class we have created? The reason it did not came, we not call it class C. So I'll say class C C1 equal to new C. We not created an object here. Once we created object, then we can call it, so that is view method. Now let me just run it and check what is it print. class C extends the main class. A extends to this class B. Okay. String cannot see capital C value, that is capital C. Class B. Okay, got it. So that is, so this method I need to close in here. Now what is the error showing? C class main. C1, it is not C. C1. You need to call the correct object, then we are going to get the output. Yeah. So what is the output we got here is 11. So 5 plus 6, we have kept I value is 5 and j value 6. So when we are adding these two numbers, we are going to get it. Just put this wrong. Here I put a C, here I put a C1. That's the reason object which we have created, it's not matched. That's it, guys. But this is how we are going to do this this inheritance, multi-level inheritance. This is how we do multi-level inheritance. Next, there is one more inheritance, like hierarchical inheritance. Hope you got what is this. If you want to take a screenshot or something like that, you can take it. I'll wait for a second. That's it. And now, and here as well, what is hierarchical inheritance? See, I'm explaining two figures as well. Now if we remove this, so class A and class B, and what is hierarchical inheritance is single class A going to have another class, subclass. I mean, it is going to have two classes. This class, let me tell this name as, I'll take it as class C. I'll take bold. Class C. Here, class C. So this is class C. Class A is going to extend both classes. Single class going to extend multiple classes. This is how we are going to write. This is how this is how it's going to be hierarchical inheritance. See, class A going to extend class B. So this is as usual. But what class C is going to do is it's going to extend class A instead of class B. This both classes are extending same parent class. Previously if you see, it was like just a second. This class C was having here instead of the here, so it's forming a hierarchical it's forming multiple inheritance, that is multi-level inheritance. Now if you see, single class is going to, one class is going to have other class C. So class B going to extend class A, class C also going to extend class A. That's class B. So one class is going to extend the properties of other previous class. C is the subclass, B is the superclass. For B is the subclass, A is the superclass. This is how it works. But for now, what is it is, both classes, both B and C are the subclasses for A. I think you hope you are getting. So B is a subclass for A, C is also subclass for A. So for this I need to call both classes, C1, P1 equal to, here I need to call both classes, P1 dot, what is the method did we call it? Did we call any method here? Display, right? P1 dot display method. We need to call in here display method. This is how we are going to call this. If we run it now, symbol J. Okay, sorry, here class extends class B, not A. Class extends class B. Okay, now if I run it, see, it's printing K value, that is it's 11, it's going to be 11, and here I did not print I value, so let me print that I value. It's going to print that I value as well. I'll tell it is plus I. So if I run it, okay, here I need to create one method and call it display view. Another method I will call like, it's not display, I'll call hello. Now if I call A equal to new A dot, I'll call here hello. Sure, yeah, here you can see I value is J, I value is 5, J value is 6. So here I'll print one more statement like I plus J equal to, now if you see, plus, so if I keep it now if you see it, the value is 5, Another value is 6. 5 plus 6 equal to 11. This is how we are going to get hierarchical inheritance. So if you see class, it's not B, it's A. Class A is going to extend class B. Array. Single array is called multiple classes. That was previously I was going. Sorry about that. It was multiple inheritance. This is hierarchical inheritance. Now if I call C 5 plus 5. So here we are going to see that J value we can't call here because we are only extending A. We can't extend both classes to the single class. We can achieve it by another method that I'll discuss afterwards. But for now, hierarchical inheritance is possible only when you call both classes, class B and class B, if they both extends A. I mean both two different classes extends single class. This is called hierarchical inheritance. So this is how inheritance works, guys. If you have any doubt, you can ask. But if you want, let me tell one general example. For in real world point of view, I'll tell like so. One more example I'd like to give you. I'll tell here one more box, and I'll tell these two are like so. Here after that I'll tell like so. Here I'll tell animal. I'll tell here this is an animal. So it's an animal, and I'll tell here it has a tiger. So real world entity animal is a superclass. So this animal you are seeing, right? This is a superclass. This is a superclass, and this tiger and this tiger is going to be a subclass. This is a subclass. I'm talking in real world real world standpoint. So according to real world, let's say animal is a superclass. In animals there can be different types of animals, right? There is tiger, lion. So these are the real world examples. So let's say here flower, and here it's going to be rose. So flower is superclass and rose is a subclass. So because why you are taking superclass as object? See, superclass according to syntax we create a superclass object, but in real world point of view superclass object should not be created because superclass object does not exist in one real world. See, here when we talk about this, right, subclass, let's assume this is a superclass, this is subclass. You can imagine animal as superclass, but then we are not certain which type of animal, but we can imagine a lion or tiger. Since it's a real world entity, so animal is a superclass object, same like it can be like any other, like if you take flower, rose, etc. And multiple inheritance is not possible by using classes. That is like single class, single subclass cannot have multiple superclasses. Rather, every subclass will have only one immediate superclass. These are some points to be remembered. And there's still some more we are going to have some more advantages of using this inheritance. Like if you can if you want more advantages, let me tell some of the examples for them. Let me tell, like, what is it, other advantages of inheritance. Those are like method overriding. We'll discuss one by one. 2, abstract. 3, interface. Like 4, next one would be generalization. 5th one, polymorphism. And last but not least, abstraction. So let me talk one by one. What is method overriding? I think I covered previously as well. Let me tell in one of the point in point of like inheritance point of view. Let me tell method overriding. During inheritance process, subclass can change method implementation. In inherited method. In inherited method, I'm telling slowly, guys. I'm not talking even fast, so that you can note it down. This process is called method overriding. It depends on 2 factors, guys. One is inheritance is must. We need to follow inheritance compulsory for this. And second one, subclasses should maintain same method signature. Method signature that is present in superclass. So this is how we are going to do it, guys. So Let me tell how it works. Let me use some examples here. Let me remove this. I'll type here hello. Okay, void hello. I'll call here, yeah, hi. Now I'll tell in class B, call same method here, hello. I'll tell here hello, hello. We'll go this and let me remove this for now. Not this much is not required. So class A closed, class B closed. Okay. Now if I call the main method, class A equal to A dot hello, B dot tell hello. There is no C method, so no C class. I'm closing it. Let me run it. Let us check what it print. Hi, hello, right? See, this hi is there in this hello method. First A class, it's in A class. So B has hello in hello method. B has hello, whereas in A has hello. Sorry, A has hi here. See, hello method A has hi. In B hello method B has hello. When I'm calling it A, it's returning A method, that is hi. What is written in A and what is written in B class, it's going to return in here in B dot B1 dot hello. If you see, same method signature. See, same method signature we have followed for both. We not changed anything. This with the help of inheritance with the same method over and with same method signature we are doing inheritance. I mean method overriding. This is how we do method overriding. What about next? What is this abstract, you can ask me? So before that, let me tell what is the purpose of method overriding. We go for method overriding when we want to change the method implementation of inherited method for a particular subclass without affecting other subclasses. So what I'm going to say is we want to affect one particular subclass we don't want to affect other subclasses. I want to give one more detailed example. Let's say I'll create a class. I'll tell it as shape. I'll tell here I'll call method. I'll say move method and I'll tell move up. Okay, here I'll call a class like shape. Any shapes you want, like I'll tell square. Square is a shape, so square extends this shape. I'm telling some real world example, square, and I'll call here I'll tell here I don't want anything here now, and I'll tell here one more shape that is going to be instead of square. Let me pull what kind of shapes do we have. I'll take triangle. Triangle shape. I'll call this move method here. I will tell to move, I'll tell her to move down. Now if I call this class like square s equal to new square, and I'll tell triangle t equal to new triangle. Okay, triangle spelling is wrong. Okay, tri. This nothing worry about the spelling guys, but I want to be more specific so that it would be correct. So triangle t, I'll call s dot, that method name what we have created is move, right? Move up, move down. I'll tell here move, I'll call, and one more method is t dot move. So if I run this code now, see s dot move, we did not return anything in s, right? If you see properly, s, that is for square, we not created anything like method like move here, but we are passing this move method. Okay, but what it's going to take is we are extending this shape, right? This shape method, which this shape class, this move method is called in here. And whereas coming to this triangle, this move method is called, if you see second output is move down, because we have called this triangle method here, this triangle class, so that's the reason it's going to give us the move method, that move down method. Move down print, this print statement, and here it's going to print move up. So this is how we are going to do overriding, guys. And with the help of method overriding, we can achieve few more things, like abstract, and another one is interface, and finally polymorphism. We'll discuss one by one. So what is abstract? First let's discuss about abstract. I think I've discussed about abstract, but let me tell what is this abstract keyword is first. What is this abstract keyword? Abstract is nothing but it is a keyword which represents incompleteness. Which represents incompleteness. There are two types of method. One is complete method, another one is complete method. You might be thinking, what is this incompleteness? One, we are going to have two methods. One is complete method, another one is incomplete method. So what is the complete method? Method which has method signature as well as method implementation. This is called complete method, or it's known as concrete method. Whereas abstract method is the abstract method or incomplete method, that is the method which has only method signature without any method implementation. Without any method implementation, this type of methods is known as abstract method. So how do we going to create? So let me tell you an example. And of course, and one more thing is like see, abstract I told like it's a keyword, right? Now let me show you. Tell class A, I'll call here public void, tell here test. What do you want to print here? Nothing. I'll tell nothing. I'll call here class B extends A. Okay, I'll tell here void test. I'll tell here public void, sorry, public void test. Now I'll print println complete the test, or test completed, or complete the test, whatever it is. Test. Okay, so I told you, right, here we need to have abstract keyword. Abstract keyword. Now if you see, what do you think you are going to get is, see, A is not abstract, does not override abstract method test. The reason why, if we declare anywhere abstract, we need to declare a class as well. If I declare only class here, if you see, class not found exception. Now if I declare here as well, test, what is it showing? Click void test. I told public void test class extends B, and test completed. Oh, I forgot to put main method here. Wait, not called main method. Let me call it here. To call it, I'll tell class main method. I'll call here main, and now if I call in here in this code, I'm going to write the code, and we'll tell here b1 equal to new p. I not created the main method. Wait, p what? Sorry, and there is b1 dot test, b1 dot test. This is to create these two things. So that's the reason it's going to give some. What is telling? Abstract method cannot have a body. Class A is closed. Oh, sorry, it's not a method, it's closing statement. And class A is closed, and test method is closed. A class. Okay, now if I run it, yeah, I was thinking this would have a case somewhere. Let me run it now. Now you're going to get it output class completed. So what is happening here is, when you create an abstract method, you need to call that class as well as abstract. So once you created the abstract method, what is the purpose of this abstract method is, we are not going to provide the details in this abstract method, where we are going to call this method in other class where we are going to provide the details. It's just like, for example, your grandfather has started to build a house, but after some time he stopped it. After a few years your father continued it and completed that abstract that is abstract completed that house. So it's like, it's not completely empty. Your father, you have taken that after some times to complete the house. So this is same like that, this abstraction works here. So you did not done anything in your test method. So you have completed the test method in a child class. So when you declare a class as abstract, I mean method as abstract, you need to declare the class as abstract as well, or else it's going to throw an error. Hope you got this abstract method, how it works. Next would be what did we complete? Method abstraction. I'm not told any definition, right? I'll type here what is abstraction as well. Oh sorry, I put in here, right? Okay, complete method, which is incomplete method, that's all. And next would be, after abstract is abstract method, next we will be talking about so let me tell interface. After this abstract, I'll call this interface. What is this interface is? So interface, it is defined as it is an abstract type used to specify the behavior of class. That is, it is interface. It is a interface in Java. Interface is a blueprint of a class. Interface is blueprint of a class which contains static constants and abstract methods. So let me tell you an example of interface as well. Where is my mouse? Sorry, here it is, right? Okay, now I'll remove this all. I'll call a new interface. This is first sample one. Sample one interface. I'll call in this void hello. Now I'll call here class what do we call this class? Let's say main, right? This is main, not main class, sorry. Sample. I'll tell hello class. Let me tell this hello class. HELLO hello. And in this hello, what is going to happen is when we talked about inheritance, we called extends, right? But in interface, if class extends class guys, but class implements interface. We need to use implements keyword here. For class and interface, if we want to put a connection, we need to put implements. So I'll tell void, I'll tell test, and I'll call here print. I'll print a print statement, and I'll call test starts. Now after this, I'll come out of this and I'll call main method class create a class main. I'll call here main method. Now inside this main I'll call this class hello h1 equal to new hello. That's all there is to it. Now if I call this h dot test method, see if what is use error or this. Okay, it's telling it does not override method. Oh sorry, this one I need to call here. This is not hello, this is test actually. Again error. So what is this? Test. Here we test. See what it's telling. Hello can't implement test in sample. Void test. Okay, void test. Test. So that I closed it properly. Yes, I did. So that I created a main method. Hello. Right, just a second. Let me try one more time. Hello, one. This time let me just put hello one. Sample, let me tell sample one. This is sample one. Now I'll call here. Let me tell this demo one. And now this I'll sell something like test one. This is all get. Let me tell this test one. I'm just checking once again. What is gone wrong? Just changing the names. Hello demo one. I'll call this d1. And this is going to be a test one. Again, let me get test T1 assignment weaker. Access privilege was public. Okay, test 1 access privilege was public. Still. Okay, I forgot to put here public. Public void test. Yeah. Okay, I forgot to put here public guys. Here. Yeah. Here what is, if you're not going to put it, it's going to be a default. It's going to be a default method. If you put only public method, then only we can call it. I forgot to put that public method, so you should not miss here public. So what is happening is, let me show you here. Created this one as sample. Let me delete these things. Now let me tell this. Okay, now I'll call this as SAMPLE sample. Let me separate this too. And let me tell here one more thing, like test 1, which is of type void. I'm calling this test method, and this is going to be demo. Down below it is going to be test1 void. Okay, now you see, let me separate these two as well. So when you are calling this interface, you see first this demo is going to this when you create an object and call this test method, is going to go into this demo class, and it's going to go to the test void, and it's going to this test void. It's going to call this void test method from this interface sample, because sample one, sorry, I mean to say this when you call this demo, it's going to go in here, it's encountered this test one, immediately it's going to go here, this test one, it's inside this now it's inside this sample one, and after that it's going to call this test one here, and it's going to print starts. So you can say like sir, what is the difference between this class and this interface? Why are we using? See, in interface we have one advantage is like we can create multi-level inheritance. See, let me show you diagram and let me draw. See, this is one, this is one, this is one, this is one. So there's a connection between these two, connection between these two, connection between this one. So and this is going to be like, so now I'm going to call here this interface This one is, let's say, interface. This is also going to be interface. Okay, and here it's interface, and here it is class. So if you see, I'll call this as samples, sample 1 2 3 something else, sample 1. Let me tell you, this is sample 1. Let's say you tell this this is an interface 1, and I'll call this one more interface sample 2, call this as test 2. So if you see, now I call this, instead of this I call interface sample, instead of 2 I call 3. Is going to extends. Previously it was implements, right? Now extends, which can extend sample 1 comma sample 2. We can call this with using this extends keyword, using this interface we can call multiple extends guys. I'll call here void call test, I'll call 3. Now in this main method I'll tell public void test1, calling this method and completing this method here. Call println first test started C control V 2 this 3, and I'll call this second test started, that is third test started. Now if you want to call these methods after this main method, now I need to call wait, this is main method, sorry, there's no need to write inside the main method. Control X, I put call here class, I'll call demo implements sample 3, call this here actually. So in this class demo we are going to call all these methods using this implements keyword, because this is an interface, we can implement it, we can't extend it, we need to implement this class using that using this. So if I'm going to call this, what is this class name, demo, right? Now I'll call this set this in class like demo t equal to call new demo, okay, and new demo, and now I'll say t dot test1, you can call this test1, t dot test, I'll say test2, t dot, call this test 3, something like this. Now let me see if it gives an error or something like that. Yeah, so if you see, we have created three interfaces. So this is if you see, this is multiple inheritance, guys. So this multiple inheritance we can achieve by using interface. So class A, let's say this is sample1 class, sample2 class. These two classes, sample3 class extends these two classes. I mean, sorry, this is interface, not classes. I mean to say, this sample1 interface, sample2 interface, sample3 interface. The sample3 interface going to extend this this remaining two interfaces, whereas this demo class going to implement this interface. So when we call this, we have created incomplete methods, right? We are completing in here inside the class, and after that we are calling this, we are closing this class and calling this main method. Inside this main method we are creating the object of that demo class and calling these methods. This is how we are going to achieve this multiple inheritance, guys. Hope you got what is this inheritance as well. Still we have something like a generalization, polymorphism, and abstraction. Interface. Sorry, there is still something called generalization and polymorphism left. So let me tell you that those two as well. What is generalization? Process of developing a method which can handle multiple objects of different types. This is called generalization. So what is generalization is? Generalization, process of creating or developing, process of creating or developing a method which can handle multiple inheritance. So you can see here, with I'm explaining at the same time typing so that you can understand it more easily. Multiple objects, not inheritance. Multiple objects of different types. This method is known as generalization. These methods are called generalized methods, and this process is called generalization, the process of developing a method which can handle multiple objects of different types. These methods are called different types. These methods are called generalized methods, and process is called, this process is called generalization. This process is called generalization. How we can create this? We need to create a static or non-static method. After that we need to create an argument. Argument should be reference with a variable, and reference variable type should be a superclass data type call the we need to call the generalize method and pass the subclass object, and this process is called as upcasting. This is how we do upcasting. So let me tell you how this is done. I'm explaining one by one, and class, let me tell, we'll take what class shall we take. Most of generally people like some people like bikes, and so that's a bike. Or let me take car, guys. Let me take a car. Most of the people like cars and bikes. I'm taking an example of car. Let me tell public void. This is the return type. We call start start. You want to start a car? Nothing inside this. Just a method. Next I'm going to call println. I call it as start car. We are going to start a car. Okay. Now I'm going to create one more class. Okay. I'm not sure about the car names, guys. I will put some check in Google. What are these car names? Top 10 popular cars. Tesla, I'll tell. Okay. So something like Tesla. Call it as where is this thing? Tesla class. That is car. This extends. This is going to extend car. There's nothing I'm going to put in here. And next I call class C car. See, this real world, this Tesla, we know a car. So we are taking this real world examples, guys. Tesla. And what are the other car names? Honda. Let me take this Honda. Honda extends car. Okay, this is done. This is a bit lengthy lecture, I believe, guys, today. Don't mind. CLASS class, but these are important. What is the other car name? Is famous name Toyota. Okay, I'm not sure about if you want to like more of this cars, you might like it, but if you want to try it, so you are passionate about something else, you can type other examples. But this is how we are going to tell. I mean, how we are going to do. I call this main class here. Class. I call main method. Now after that, what we are going to call is Tesla t equal to new Tesla So I'm not gone into this generalization, guys. Just I'm going to explain what it is. Why we need to use generalization? Like I mentioned, did I mention the definition of generalization? Yeah. Okay. Now you're going to know. Tesla, and what is this? Honda, right? Honda H equal to new Honda, something like this. And next, what is this? Toyota, right? So what is the problem? Equal to new Toyota. Now if you see, I need to call this t dot start method. Did I create? What is the method I created above? Yeah, start, right? T dot start I called. So semicolon and h dot start and t dot start start. Still I'm not got into it. Just I'm going to explain the what is the issue now. I'm going to print it. Is there any issue here? Toyota T is T is already taken. I'll take T1. T1. Okay, shortcut. But now if you see this thing, we are starting all these objects. We need to call these objects, each and every object, multiple times. So this is just where we need to call this same method for these three objects differently, different times. I mean, three times, multiple times. So it's going to be code something like it's a repetitive code. Same thing we are doing multiple times. To avoid this thing, we are going with generalization. Getting the point. Now how we are going to do is same thing. Here everything is same. So what we are going to call is, inside this class main, before I start the main method, I'm going to create one public static, sorry about that, static void I call move. Inside that I'm going to pass this car C. I call this now C dot, what is this, start method or move method, what is, okay, start, right? start. So now going to this start method. So what I'm going to do is just remove this thing and now move I call new, pass that names Tesla, call it here, close this thing, semicolon. Same thing, instead of Tesla I'm going to call just call it here three times, control V, this is Tesla, this is Honda, last one is Toyota. Now if I print this, same thing. So if you see, previously I was repeating that same code, calling this same method multiple times, h1 dot start, h something, that dot start, t dot start, something, different things I called multiple times. But now what I've done is called this inside this move method I passed that class, that object called using this method. With this I was able to avoid this repetitive code. This is how we are going to do generalization, guys. So what we have done is generalize that static method. So we have generalized the static method. See, this car is static. I mean, this we not changed it. It's similar. So we created one move method here, and we have called inside this move method we called all that car names. That's the way we have reduced this. We have avoided this repetitive code. Next, there is one more thing like called specialization. So till now we have discussed only this one, generalization. Of course, we have something called specialization as well, but I think for now we are just I'm going to tell like what it is. What is its definition? It's like a process of developing a method which can handle multiple objects of same type. This is called specialized. These methods are called specialized methods. Instead of this different types of object is going to take of similar same type objects. That's all. Same. I mean same type. That's all, guys. Maximum. That's max, not max difference. That's the reason I'm skipping that. But still, we have two things: polymorphism and abstraction. So what is this polymorphism? Just give the definition of that. But I'm going to discuss this polymorphism in depth. Oh, sorry. Here it is. Okay. Polymorphism. Single entity having multiple forms is called polymorphism. I mean, single entity having multiple forms. Entity having multiple forms is called polymorphism. This is called, that's it. This is called polymorphism. Single entity having multiple forms is called polymorphism. So, of course, there are two types of polymorphism. They are, first one is runtime polymorphism, and other one is compile time polymorphism. So what is runtime polymorphism? Call to override the methods is decided during runtime. Based on the object creation, this process is called runtime polymorphism. Runtime polymorphism. So call to override method is decided, if I'm wrong with the spelling, decided during runtime. Okay, next one. Okay, this is achieved this week. We can achieved by using inheritance, method overriding, generalization, and upcasting. And compile time polymorphism. Call to override the method decided during compile time. Overloaded method. Call to overloaded method decided during compile time. Call to overloaded method decide during compile time based on arguments. This is called compile time polymorphism. This is achieved by using method overloading. This is achieved using method overloading. So let me tell you some examples of runtime polymorphism first. An example of runtime polymorphism. Like I create an interface. I call here like animal. And I'm almost taking all the examples or similar examples, guys. Noise, nothing I would public. Now I call the class here. Call the class like lion implements animal, tiger belongs to animal. Okay, inside this now I'll call public void noise. Okay, that's done. Call println. I'm going to call lion noise, or I'll take more, it would be good. Roar, lion roar, lion has roared or something like that. And I'll call the same method inside here tiger. I'll call this as tiger roared, and I'll tell here leopard roared. How did I get that? My thing is, you need to press Windows press B. You're going to get what you copied previously. Okay, allow you went right. Sorry, leopard roar. So lion have roared, leopard have roared. Now inside the main method, instead of this, I'll call make some sound, because we are talking about noise. So I'll call it has, I mean, I talked about roar, animal. I'll call it animal a dot roar. So done. Now inside this main method, what I'm going to say is, just like previous example, I'm just modifying bit. It's lion leopard tiger, and the final one is leopard. Yeah, everything is wrong. Okay, everything looks fine now. And so let me call this, let me run this. Okay, not reach. Okay, this main method, this leopard tiger class, this class is closed. Oh, okay, interface I forgot. Sorry, that is noise, right? It's not, it's actual semicolon, I put that. Now if I run it, see what it is. Print interface expected. Okay, what is it saying? No interface as expected. Oh, extremely sorry. It's implements. Control R. Okay, sorry. Let me put it. No bypass this. Control V. Control R. F. Replace it. This extends with, I'll call MENTS implements. Replace all. Now just copy it, open it, paste it. That's implement, sorry. That's interface, right? We need to use implements, not extends. So now if I call interface animal void noise class line implements animal void roar roar tiger roar. After that what is string roars leopard roar. After that class main make some sound animal a dot roar roar you. Okay, after that calling these methods. Okay, let me try it out. What the error is? Let me check. Lion is not abstract and does not override abstract method. Interface lion implements sorry it is roar not noise. Still it's showing the same method. Move 24. When we edit it, we need to check whether we have done correctly or not before we run it. Now we cannot find the symbol. Animal string a dot roar Control C, Control P. We need to make a sound, not roar. We need to call this method. We need to call this method. Yeah. So we are not we saw. So inside this main we have called this make sound. So inside that we have passed this roar object. So we are calling this roar object inside this make sound. So we need to call this make sound, not roar. Sorry. So when we call this, we are going to go into this make sound, and it's going to a dot roar animal A. After this, it's going to do this roar, and it's going to check this. Which one it's going to check based on that. We are called a lion, so it's going to go into the lion first one, and it's going to print that roar. So how it's going to work is, so this is 1 2 3 4, and now 1 2 and 3. Now if I print in here, this is animal, so this is animal, and it's going to be lion lion, tiger, leopard. So it's going to, this is an interface. So the public noise is going to check and check this lion, tiger, and leopard noise. I mean that roar. That roar is going to check whether it's lion roar or a dot roar. When we call in this line, it's going to go into that lion roar, and it's going to print it. And it's going to, when we call tiger, it's going to print the tiger roar, and leopard is going to print the leopard roar. That's how this is happening, polymorphism. And of course, this is just compiled time. Sorry, that is runtime polymorphism. This is decided during runtime what is going to happen. So, but now if I discuss about compile time, I call this class. I create one new thing, add method public static add, return type would be void add. Now if I add it, what it's going to print is, I'll print int a comma int b, something like this, pb, println a plus b. Like I'm going to call one more method, create one more method with different arguments. Call this, instead of int I'll call b as double double. I'm going to call here c b. I'm going to call double double double. Did double it double, I call this int. Okay, now I'm going to call main method, class main, and I'm going to call in here add method. Add that class which was it. I'm going to call add. I'm going to say 6, 8 and dot add 4, 5.6 and dot add dot add. I call here, what is left? No, both double and 8. Now after this, so during this compile time, the 3 are called, not 4. 4, right? 6, 8. Yeah. See, during compile time, it's deciding that first which object is called add a, 8, 6 and 8. So there are 6 and 8. So it's going to check in here which one you need to select. Both are integers, so it's selecting the first one. After that, it's taking 5.5, 5.4, 5.6. It's both are double. This is taking this one, this third one, calling this third one and going to print it. When it's coming to here, first one is integer, next one is double. It's checking where is this kind of thing, where is double and integer. It is finding it integer and double. This is second one. You is going to go into this method and going to print it. Likewise, last one, double and int. Int and double and int. So it's going to check where is this double and int inside this method. So it's going to go here and it's going to print this addition. Same thing, but it's going to decide when during the compilation which method it need to call. So this is known as compile time polymorphism. This is decided based on arguments, guys. What type of arguments you have passed. This is how simple it is. Told this one. Now polymorphism is also done. The last thing, abstraction is left, I believe. Abstraction, encapsulation is left. These two are the main important topics. Abstraction and there is one more thing like polymorphism and abstraction. Let me finish this last two topics, guys. With this we are going to done of all most important topics main important topics in Java. This is process of hiding, method, implementation, details, and providing only method, providing only access only to method signature. This process is called abstraction. In simple terms, hiding the unnecessary details from the user and providing give access to only details which are necessary. It's known as abstraction. So let me tell you an example how this is done. Abstraction. So I'll tell a class, same like I'll tell one class. Sorry, first one. We remove all this. Interface, like as usual, I'll take A. I'll call here void. I'll tell dance something. And now I'll call class P implements A public void dance. It's quite a bit, sorry, void dance. Yeah, okay. I'll print rm nice dance. Something I've written inside this print statement, guys. Now this was closed. Now I'm going to call class C public A or fetch object I think this will be tough, but I'll tell you some easy way. A into new B return A. Actually, we need to create one more class. That is class main. Class I'll call main. Main. And I'll call here. What did I call here? Class was C, right? C equal to new C. Okay, let me check what is this. Class B. Why it is so many anything? Okay, let me check. A, so the A1 equal to C dot. What is that? We have created something like fetch object, or fetch object, calling in here fetch object and passing it in here. I call A1 dot dance. Now if I run it as class A. Okay, I put capital C. Okay, sorry about that. That's what I was thinking. Why it is showing error? Yeah, okay. So if you see here, we can call this, we should call this in a new class. You should not print in here. I'm using this, which I don't want to create a new class, but I can call like main2 dot java. Okay, I call it in here, pass it in here. I call this main2. If I run it, see what is happening here is, we are going to show to the user only this class, this main2 class. We are not going to show this main class. So what happens is, abstract, we are hiding the unnecessary details. I mean, this object, what is this object fetch going to do? What is this object dance going to do? What is this thing? What is stored in this methods? Where is this print statements? This is nothing is needed for this user. He is not going to get the information unless until he go to here how this class is going on, how this interface is happening. Only then he is going to know what is happening here. That's the reason we are hiding we are hiding this data. We are only displaying the class, this class to the user. That's the reason we are telling it as abstraction. We are not showing the method implementation, how these methods are implemented, how these classes are implemented, other classes, the C1 object, how these are implemented, how this method fetch object is implemented, how this dance object is implemented. We are not displaying to them. This is how we are going to show abstraction. So this is how we have done the abstraction, guys. Still there is one more topic, last topic, guys. Sorry if you are bored, I'm sorry about that, but please bear with me for a few more minutes. We'll wrap it up quickly. Encapsulation. I've given the example of abstraction, right? So that's how we are going to do that. Now let me tell you, abstraction, polymorphism, one more thing is 7th one. Encapsulation. So this is the last one which I'm going to discuss for today, and we'll wind up finally. Encapsulation. What we are process of binding data members with member functions into single unit. is called single unit called class. This process is known as encapsulation. Process of binding data members with member functions into a single unit is called encapsulation. So let me tell you how this works. I'll tell delete this. Yes, I'll call class. What do we call this class as? Let me show without first how we are doing without encapsulation. Let me show the encapsulation. Class item. For example, calendar, public, int, month. I'll call this class as, now I'll call main class, and in this I'll call main method, call calendar c1 equal to new calendar. I'll call here c1 dot month 2 7, something like that. See, so what is the issue is calendar you're seeing, right? And this month number. So these are public to the user, which so user also can see this thing, so that what happens, right? Users can misuse this data. So that's the reason, because it's public, so that's the reason we are preferring encapsulation. So in order to perform encapsulation, we need to have one thing is one method in that variable should be declared as private. This is the main important thing, and provide the access to the variables through public methods. So I'm creating a public method, public. I'll tell void means nothing is empty. I'll tell assign int and th month. I'm going to call in here, and I'll say if th month greater than or equal to 1 and th month less than or equal to 12, this dot th month number equal to month number, else I tell println invalid, something like this. That's all. And now after this I'll create one public void this display. That's all. Now I'm going to create this method object method here and give something like switch method or something and pass this month in here. Now I call case 1 println. That would be first month would be January. I'll tell January something like this, and I'm going to break it. Break case 2. February, and I'm going to want to break just like that. Break it. That's all. Now I'll put default. That's enough. I will default, and after that I'll say println and say invalid. Now this display method is also done, so I'll call main class main. Oh, sorry. Main is also already called. I would say here instead of that co dot created assign. Inside that I'll call 1. That's c1 dot display. That's all. Display. Let me check what prints an area or something like that. 5th one, right? Where is this? List of month. Control V. Yeah, see, it's printing January. So because we have assigned here one value, so it's going here and it's checking whether we have entered correctly or not first. So it's going to assign that one value and it's going to check this 1 month equal to 1. After that, this month value is 1, so it's going to in here and it's going to check first case value is matched with 1, so it's going to give January. And if I say instead of 1 assign, I'll say 2, and if I run it, you're getting February, right? Now if I say 3, see, it's giving invalid because we have given only till case 2. I mean till February I have given. I have not gone to anywhere. So this is how we are going to do with encapsulation. So declaring variable is private and providing access to the variables through public methods. This is how, see, you have called this as private and calling this public methods. With these public methods, I'm calling this private number, this private integer, so private variable. So with the help of that, I'm able to perform encapsulation. If you hope that's it for today, guys. I hope I know that today the lecture was too heavy or too big. You can watch it again one more time if you want. If you like my lecture, please like, share and subscribe to my channel. If you're new to the channel, please comment if you want to know even more about something like this. Thanks for watching. Please comment if you have any doubt.